As we transition into Chapter 11 here, you're going to notice that Section 11.1, we are looking at areas of triangles and parallelograms. And this is, a lot of this material in this chapter is going to be relatively familiar to you, although there are some different ideas that we will discuss that are probably going to be brand new. So as we get in, you're going to notice on your notes that there are a lot of postulates and theorems that we're going to go over real quick, but a lot of these, again, you already know. So first of all, vocabulary, bases of a parallelogram. Remember, the bases in a parallelogram are the parallel sides. So that would be one set of bases, and then if I mark the other sides as being parallel with red, then those would be the other bases. So there's two sets of bases in a parallelogram. Okay, the height of the parallelogram is the shortest distance between the bases. Okay, so for example, we agree that this blue base and this base are the two bases. So oftentimes what you'll see in a parallelogram is they'll take one of the bases and they will extend it out. I apologize for that not being super straight, but and then what you'll see is they will drop down a height right here and call that perpendicular, and that would actually be the height of your parallelogram. Okay, and so that's the way you'll see height in a parallelogram oftentimes. So the first postulate theorem here says the area of a square. We already know this. The area of a square is the square of the length of its sides. In other words, we all know that if this is x, then this side has to be x, and this one's x, and this one's x. And so to find the area would simply be a side length squared. Okay. Another postulate or theorem that we are, should make sense to you is that if two polygons are congruent, then they have the same exact area. We already know that if congruent means same exact size, so it should make sense that if two shapes are the same exact size, then they have the same area. Area addition postulate simply says the area of a region is the sum of the areas of its non-overlapping parts. For example, if I look at this diagram here, it appears to be a rectangle, but long story short, I could also divide this up into two triangles, triangle 1 and triangle 2. And then what I could do is I could find the area of triangle number 1, then find the area of triangle number 2, and then simply add those together to find the area of the entire figure. So that's a pretty straightforward idea, really. The area of a rectangle, we already know this. The area of a rectangle is the product of its base and height. And the area of a parallelogram has the same formula. The area of a parallelogram is the product of a base and its corresponding height. Okay, and again, we'll kind of look more at this as we get rolling with some examples. The last two here, the area of a triangle is 1/2 the product of its base and its corresponding height, so 1/2 BH. And then this last one is kind of a different one, okay? It says the area of a triangle given the two sides and the included angle is blank, okay? So for example, if I know this side is 4, this side is 5, and say we know this angle measure is, 66 degrees, then what you can do is you can do A equals 1/2 4 times 5, whoops, do that again, sorry about that. 1/2 of 4 times 5 times the cosine of the included angle. Okay, and so that's what we're looking at. 1/2 the two sides times cosine of the included angle. Alright, so it says find the area of each polygon. Okay, so this first one, we'll assume it's a parallelogram. They probably should have marked this. If I do this, remember back a few chapters ago, we know that's enough to say it's a parallelogram. Opposite sides congruent means it's a parallelogram. So A equals base times height. You'll notice that you are given actually two different bases here. You're given that this base is 9, and you're given that this base is 8. However, we only know one of the heights. Okay, if I look at the base that's 9, I know the corresponding height. When I look at this base and this base, the distance between them is that 4 there. So we're going to use 9 times 4 to find our area. And we all know that 9 times 4 is very simply 36. Okay, and we should probably put 36 units squared since we are talking about area. Alright, example B. Again, it's a triangle. So as soon as you see a triangle, you probably want to write down A equals 1/2 base times height. And so now what we're looking at is, here's the height, right? I know it's the height because it's perpendicular. If I'm using that height, I have to use this base. And so I have 1/2. My base is going to be the sum of these two numbers. So 45 and 21 make 66. So I have 1/2 times 66, and then the height is 28. Alright, so I do 1/2 of 66, which is 33, times 28, and finally 33 times 28. I'm going to go ahead and grab my calculator real quick. Alright, 33 times 28, I believe, should be 924 units squared. And finally, we'll look at this example down here. Again, it's a parallelogram, right opposite sides parallel, so it's got to be a parallelogram. We know this base is 17. We know this base then has to be 17, and we know the distance between those two bases, since it's perpendicular, has to be 7. So again, parallelogram, start with your formula, plug in what you know. The bases we're using are 17, and so the height that we have to use is 7. 17 times 7 is going to be 119 units squared. So again, these are just using formulas, identifying bases and heights, and then plugging into your formula. It says the base of a triangle is 4 times its height. The area of the triangle is 50 square inches. Find the base and the height. As soon as you know you're talking about area of a triangle, A equals 1/2 BH. Plug in what you know. The base is 4 times its height. Okay, so if its height is h, then its base is 4 times the height. So the base is 4 times the height. Okay, so now you'll see what we can do here. And they also tell you the area is 50. So the A is 50. The B, we don't know what the B is, but we do know it's 4 times the height. And so we end up with something like this. And so it says 50 equals 1/2 of 4 is 2. H times h is h squared. Divide both sides by 2, so 25 equals h squared. Take the square root of both sides. The height has to be 5. And since we know the units here, it's inches. So the height is 5 inches, which makes the base 4 times that, which is 20 inches. Okay. So it's still the area of a triangle problem. It's just a different context. You're solving for different things as opposed to just being asked what is the area. Right? A parallelogram has an area of 133 square feet, a height of 19. What is the length of the base? All right. So again, parallelogram, A equals base times height. Okay. A is 133. We don't know what B is. That's what we're asked to solve for. We know the height is 19, and so you'll see pretty straightforward here. All you're going to do is 133 divided by 19, and when you do 133 divided by 19, pretty sure you should just get 7 for your base. Okay, and again, we know our units here are 7 feet. All right. Yet another example here. It says a robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. How long does it take for it to clean a carpet covering a room with the dimensions shown below? So the first thing we need to know, it says 2 square meters in 8 minutes. So the first thing I need to know is area. Okay, so you'll notice I can cut this shape into 2 figures like this. That's going to be 5, right? Because those sides have to be equal. This piece right here is 5. If this whole thing is 9 and that much is 5, it makes this piece 4 meters. All right, and then we can kind of go from there. Okay, so I've cut it into a square and a rectangle, really. All right, so the area of the square equals base times height, which is 5 times 5, which is 25. So the area here is 25, and then the area of the rectangle is, again, base times height. Base is 9, height is 4, so that's 36. So the area of the whole figure is going to be 36 plus 25, so that's 61 meters squared. And the vacuum cleaner can clean 2 square meters in 8 minutes. Okay, and so there's a couple different ways of doing this. What you can do is you can say, okay, if it cleans 2 square meters in 8 minutes, that means how many of those little bits of time do I have? So in other words, divide this guy by 2 square meters, and what you end up with is 30.5 units of time. And that there's 30.5 units of time, and each unit of time we know has to be 8 minutes. And so what you do is you'll end up doing 8 times 30.5. So I do 8 times 30.5, and I get 244 minutes. for this vacuum cleaner to vacuum this room. Okay, you could have set up a proportion. Okay, you could have said, okay, the whole room is 61 over how long it takes, and we know that it can do 2 square meters in 8 minutes. And you could have cross-multiplied and solved here. Regardless of what you end up doing, you're going to get the same answer, 244 minutes. And finally here it says the area of a triangle, SAS formula. You'll notice here I actually goofed up earlier. I said cosine. It's actually the sine. My apologies. So make note of that on the notes. It's sine C, not cosine. Okay, it says in a triangle where AB are known and C is the measure of the included angle, 1/2 AB sine C. Alright, so for example, we'll just do one of these, and then we'll talk more about it tomorrow. If I look at part A equals 1/2 my sides times the sine of the included angle, 134. And at that point, you'll have to have a calculator. I'll be honest, the calculator I have does not have trig functions on it, so I can't do that. But the biggest thing is that you just see how it's set up. So you'll notice, like in some of these, like in part B, you have to use this angle, because you're going to use 6.8 and 5.5, so you got to use the angle between those sides. So you'll have a little bit of work there to find that missing angle and then use this formula. Okay, so really not anything too tricky here. It's just memorizing a different formula for the area of a triangle depending on the information that you're given. And so that's all we're going to roll with there in section 11.1. Any questions you have, bring them to class, and we'll take those first thing in class.